हेलो फ्रेंड्स, वेलकम टू माय चैनल। मैं हूं आपका दोस्त महेश कुमार और आइए स्टार्ट करते हैं सम इम्पोर्टेंट पॉइंट्स रिलेटेड टू हाइड्रोस्टैटिक फोर्सेस ऑन surfaces. Friends, here you see the liquid is in container. Here liquid or some dam is there, gate is there. Here liquid is there and here liquid is there. Friends, in all cases, the liquid is at rest condition. Here, dam is there, so this liquid is in rest condition. Here also we are considering that liquid is at rest condition. Here also, because here you see the container is at static condition, so liquid inside also the container will be static condition. We can assume if we are not giving any motion to the liquid. अगर हम बाहर से motion देंगे तो क्या होगा? It will be in moving condition, but we are not giving anything. So the container is at rest condition and liquid inside the container also rest condition. Getting friends? Now we will consider this part only. Friends, what happened if you apply some relative motion to the container in which liquid is there? So what happened? Some motion will be there. Let's see. We will see. Now friends, you see here the container is there. At this stage the container is at stationary. In this a liquid is there. Its free surface is AB. It is in horizontal. Some wheel we will provide here for giving the motion. This part now we are applying some acceleration here. Now we come to this point. Here we are providing some acceleration. So what happened? This container will move in this direction. So now it is moving in this direction. So this part or this end is back end or rear end, and this is the front end. Getting friends? Now friends, what happened while moving this one? Initially, the particles of the liquid will move little bit, or we can say relative motion will be there initially in the particles of the liquid. But what happened after some time, it will attain a new free surface and it will be in a static condition like this, because this container is moving with constant acceleration. So क्या होगा friends? Liquid particle initially तो move होगा, but after moving it will get a new free surface. It means friends क्या होगा? The liquid क्या होगा? In this direction में आकर के वह रेस्ट कंडीशन में आ जाएगा. इट मीन्स फ्रेंड्स क्या होगा? द बैक साइड में लिक्विड राइज होगा एंड फ्रंट साइड में लिक्विड फॉल होगा. हम देखेंगे इसको क्यों ऐसा होगा, बट आप समझिए कि बैक साइड में लिक्विड हमारा राइज करेगा एंड फ्रंट साइड में फॉल करेगा, और इस केस में हमारा जो है लिक्विड रेस्ट कंडीशन में आ जाएगा. एंड like this only the liquid will move along with the container. It means friends, the container and liquid came in rest after some time. So अगर यह रेस्ट कंडीशन में आ जाएगा and this is the new free surface of the liquid, then क्या होगा फ्रेंड्स? हम इस पर जो है हाइड्रोस्टैटिक लॉ अप्लाई कर सकते हैं, because it is in rest condition. There is no movement of this liquid surface if it is moving with constant acceleration. So here also we can apply the hydrostatic law. We can find the pressure forces and how much pressure is applied each and every point we can determine. Getting friends? Hope everything is clear. Now here friends, what I told, same thing is written here. Now the liquid container is moving with a constant acceleration a. The liquid particle initially will move relative to each other, and after some time there will not be any relative motion between the liquid particles and boundaries of the container. The liquid will take up a new position under the effect of acceleration imparted to its container. Getting, friends? The liquid will come to rest in the new position relative to the container. The entire fluid mass move as a single unit. Since the liquid attaining a new positions is in static condition, so relative to the container, the law of hydrostatic can be applied to the determine the liquid pressures. As there is no relative motions, so between the लिक्विड पार्टिकल्स, हैंस क्या होगा फ्रेंड्स, यह तो रेस्ट कंडीशन में आ गया है, लिक्विड केम इन द रेस्ट कंडीशन, सो इन दिस आल्सो देयर इज नो मोशन, सो शियर स्ट्रेस एंड शियर फोर्सेस क्या हो जाएगा फ्रेंड्स, जीरो हो जाएगा, शियर स्ट्रेस एंड शियर फोर्सेस विल बी जीरो. गेटिंग फ्रेंड्स? सो the pressure will be normal to the surface in the contact with the liquid. So यहाँ पर हम प्रेशर फाइंड करेंगे तो प्रेशर क्या होगा, नॉर्मल कंडीशन में होगा. फ्रेंड्स, वन मोर पॉइंट इज देयर हियर, यू सी. अब हम क्या करना है, यह तो इस स्टेट में आ जाएगा. नाउ वी कैन गिव एक्सेलरेशन in two way. Either we are providing this acceleration in horizontal directions or in vertical directions. तो हम हॉरिजॉन्टल डायरेक्शन में मूव करेंगे तो क्या इंपैक्ट आएगा, जब हम वर्टिकल एक्सेलरेशन देंगे तो क्या इंपैक्ट आएगा, और अगर हम जब दोनों एक्सेलरेशन देंगे हॉरिजॉन्टल एंड एक्सेलरेशन, देन व्हाट हैपन वी विल डिस्कस. गेटिंग फ्रेंड्स? नाउ लिक्विड कंटेनर सब्जेक्टेड टू कांस्टेंट हॉरिजॉन्टल एक्सेलरेशन, तो क्या इंपैक्ट आएगा. हियर यू सी फ्रेंड्स, सेम थिंग like this, the liquid is there, initially it is at rest, now we are giving the horizontal acceleration. Because of this horizontal accelerations, this is the back end, so back end liquid will shift to the back end and drop to the front end, and it will attain a new free surface of the liquid, initially this is the free surface of the liquid, now it is attaining a new free surface of the liquid. Let's suppose it is making an angle theta here, it is making theta with the original, this is the x, this is the y, it is moving with a constant acceleration a. Friends, now we consider one small element at the free surface C, small element C at the free surface in the new position, a new surface condition of the liquid. So क्या होगा फ्रेंड्स, here I am taking the bigger part of the this one, this is the C element, so now we are considering the C element, this is the C element. So forces acting on the C element on C, which type of forces here, it will work on this element. गेस कीजिए फ्रेंड्स, क्या क्या फोर्सेस हो सकते हैं यहाँ पर? एक तो प्रेशर फोर्स होगा इसका, जो लिक्विड इस साइड में है तो प्रेशर फोर्स इस डायरेक्शन में लगेगा। ओके, इसका कुछ वेट भी होगा, सो डाउनवर्ड लगेगा। गेटिंग फ्रेंड्स? हियर the weight of the particles, so it will work at the downward direction. Pressure forces will work in this direction. Getting? Pressure forces will work in this direction, and it is moving with acceleration, so here accelerating force will also work. So here friends, you see here this is the element. Because of this pressure forces liquid this side, so pressure forces is the normal to the surface, so this is the pressure force. P is the pressure force normal to the free surface, so in this direction it will work. Mg is the weight of the element. Weight of the element, it is downside, it will work downside mg. Now it is moving with some acceleration, horizontal acceleration, so accelerating force, mass into acceleration, because the element have some mass, so mass into acceleration, so the force it will work in this direction. We know that friends, here angle theta is there, here this is the angle theta, here this is the angle theta, so same here this angle theta is there, this also angle theta is there, so this is the 90 degree, so this is the 90 minus theta, and here also this is normal to the free surface, so this angle is also 90 degree, this angle is also 90 degree, so here 90 minus theta, so what it will come, it will come theta here. Okay friends, now we will resolve these forces in vertical and horizontal direction. So friends, you see here vertical direction में क्या हो जाएगा? If you consider horizontal directions, horizontal direction में क्या होगा? First we are considering horizontal direction. So here क्या हो जाएगा? In this direction, यहाँ पे क्या होगा? This P, sorry, this is the P sin theta हो जाएगा. तो this point is P, sorry, this is the theta ना. So this will be P cos theta, and here in this direction P sin theta. So here sin theta it will come, and in this direction P cos theta will come. So P sin theta and this accelerating force also same directions. So क्या हो जाएगा friends? Plus this m into a equal to 0. So P sin theta plus mass into acceleration will be 0. So क्या हो जाएगा friends? Sigma h is equal to 0. We are finding this one. So from here the P sin theta is equal to minus, if you send this one is equal to in this direction, so minus m into a it will come. This is equation 1. Now similarly here vertical force, so we are resolving the vertical force, sigma v equal to 0, sigma v equal to 0. So in this case friends क्या हो जाएगा? Here you see here what it is coming, P cos theta it will come, it will work in the upper direction, and mg is working in the downward direction. So from here this P cos theta minus mg equal to 0, or P cos theta equal to mg. This is the equation 2. Now divide the equation 1 with equation 2. Equation 1 I am dividing with equation 2. So from here P sin theta upon P cos theta equal to minus m into a upon m into g. So here m to m cancel out, here P to P cancel out. So sin theta upon cos theta is equal to tan theta equal to minus a by g. Friends, this tan theta what it is showing? It is showing the slope, and here the negative direction, negative sign showing the downward. So slope is equal to what? Here no square is there. It means the tan theta, which is slope, is a straight line with downward direction. Getting friends? Here the a by g is constant, hence the tan theta will be constant, and the negative sign shows that the free surface of the liquid is sloping downward. That's why friends, that's why here, that's why the liquid here downward direction it is coming. It means here it will go up and here it will go down. It means the liquid will shift to the back end and drop in the front end. Getting friends? Because of this slope we are able to find. Hence the free surface is a straight plane inclined down at an angle theta along the direction of the acceleration. Getting friends? So this side में क्या होगा, down होगा, and back side में क्या होगा, up होगा. Now फ्रेंड्स हमने डिटरमाइन कर लिया है स्लोप कितना होगा. फर्स्ट पॉइंट इज वी हैव टू डिटरमाइन द स्लोप. सो स्लोप कितना होगा, स्लोप इज इक्वल टू माइनस a by g, or this negative only showing the direction of the slope. The magnitude is equal to what, a by g is the slope value. Okay friends. So slope we are able to determine. Now friends, we have to determine how much pressure is there. First, we already determined here what is the slope. Slope is equal to minus a by g. Now we have to determine what is the pressure. Pressure at each and every point of the liquid. So expression for the pressure at any point d in the liquid mass subjected to horizontal acceleration. It means friends, see here, let's consider a container like this. I am making, this is the container I am making. For proper understanding, I am making this diagram. This diagram I am making slowly so that the things will be clear. Okay friends. So this is the container. Initially the liquid is up to level this. Now it is moving with some acceleration a. So what happened? The liquid surface, free surface will shift like this. This is the point, this is point A, and this is point B. Now friends, we have to determine the pressure. Suppose at this point D, we have to determine the pressure. What is the pressure at this point? In this situation means the container is moving with acceleration a, and the liquid is at a new position, new surface AB. So in this condition, at point D, what is the pressure? Point D, what is the pressure? So for this, we are making a prism. This point, is a small element, this small point is there, D. So let's make a prism up to this free surface, up to this point. This is the center point. So from here at point D, we are making a prism like this. Its height is equal to, or we can say depth equal to h. Okay friends, from here h height, h depth is there. So friends, at this point, what is the force will work on the top side, because top side environment pressure is there. So P naught is the environment pressure, and here the small area, we are considering the small cross sectional area dA is there. So here top side also dA is there, and P naught is the, here this P naught is the atmospheric pressure and dA is the small cross sectional area of this prism. So P naught into dA is working on the top point, and bottom what pressure will be there. Let's suppose bottom pressure is P, and it is working in the cross sectional area dA. Getting friends? So this P into dA is the bottom side, it will work in the upward direction, and this P naught into dA, it will work in the downward direction. Now friends, here the liquid weight also will be there. So here liquid weight also be there. So rho g into V, it will work in the downward direction. So three forces is there. This atmospheric pressure is downward direction, weight of the prism, it will work in the downward direction, and this at this point pressure is equal to, pressure force is equal to P into dA, it will work in the upward direction. Getting friends? So here already we discussed forces acting on the prism DE. Let's suppose here this D and E is the prism. So here it is working atmospheric pressure P naught into dA downward direction, weight of the element rho g into V, or we can say rho g dA into H downward direction, and pressure force P into dA is the upward direction. Getting friends? Something clear? Okay. Now friends, now what we will do, here you see, so net we will find the total vertical force here. Total vertical force here we will find. So sigma V equal to 0 we will find. So from here what is there? P naught into dA downward direction, rho g H into dA weight of the liquid in downward direction, minus P into dA pressure force in upward direction. This point is upward direction, so it will equal to the 0. Friends, here you see one more point. It is moving in horizontal directions. So whatever acceleration is there, it will work in the horizontal directions. There is no movement in the vertical direction. So vertical direction acceleration will be 0. Correct? So from here you see friends, what we will do, this all term we will take a minus. So what happened? If you see here minus in both side, so क्या हो जाएगा friends? This minus and minus plus हो जाएगा. So P into dA plus this term minus P naught dA. This term also will be minus rho g H into dA, like this. So dA cancel out, and what is left? P here, P naught minus rho g H. So rho g H, this term will send this side. So P minus P naught equal to rho g H. Friends, here this is the atmospheric pressure, and this is the pressure which is at point D. So friends, if you are taking the gauge pressure, so in gauge pressure क्या होगा? This atmospheric pressure 0 होता है. So if you are considering gauge pressure at point D, so this term will be 0. So P equal to what? Rho GH. जो भी प्रेशर होगा एट गेज प्रेशर हम क्या लेते हैं? गेज प्रेशर हम जो है एटमॉस्फेरिक प्रेशर को बेस मान के लेते हैं. इट मींस एटमॉस्फेरिक प्रेशर एट दिस पॉइंट इज इक्वल टू 0. गेज प्रेशर में एटमॉस्फेरिक प्रेशर को हम 0 काउंट करके चलते हैं. सो गेज प्रेशर क्या हो जाएगा? एट पॉइंट डी P इक्वल टू rho g H, और वी कैन से फ्रॉम हियर द प्रेशर हेड इज इक्वल टू H इक्वल टू P by rho g. Getting friends? So here also the same thing it is coming. P is equal to rho GH, whatever static law, hydrostatic law it is saying, same thing it is coming in this also. So H is equal to P by rho G also it is coming. Getting friends? Hence, it is clear that pressure head P बराबर rho G at any point in the liquid subjected to a constant horizontal acceleration is equal to the height of the liquid column H above the point. It means friends, P बराबर rho G H is equal to what? H is there. So at any point यहाँ से क्या हो जाएगा? अगर हम सेम थिंग है, अगर यहाँ पर लेंगे तो प्रेशर हेड कितना हो जाएगा? H की इक्वल होगा. अगर हम यहाँ पर लेंगे एट दिस पॉइंट लेंगे तो प्रेशर हेड कितना हो जाएगा? एच के मतलब कि उसके इक्विवेलेंट हो जाएगा. अगर यहाँ पर कितना लिक्विड है तो यहाँ पर लिक्विड है तो प्रेशर हेड इसके इक्विवेलेंट होगा, और यहाँ तक लिक्विड है इसमें तो प्रेशर हेड जो है इस पॉइंट के इक्वल होगा. गेटिंग फ्रेंड्स? So at each and every point we are able to find. Same thing is saying here. Hence it is clear that pressure head P upon rho G is equal to H. So at any point in the liquid subjected to a constant horizontal acceleration is equal to the height of the liquid column H above that point. So from here we are able to find the pressure head at different point. Now friends, this point we are giving the height h1 because it is liquid is shifted, so we are giving some value. So let's suppose here the height of liquid is h1. Here height of liquid is h1 and here the height of liquid is h2. Getting friends? Here liquid is h2. Here this side liquid is there. So friends, यहाँ पे क्या होगा? Because of this liquid, प्रेशर कितना होगा एट दिस पॉइंट? रो जी एच. इस पॉइंट पर प्रेशर कितना होगा? रो जी एच एच वन, सॉरी रो जी एच वन, बिकॉज दिस हाइट इज एच वन. हियर एट दिस इन पे कितना हो जाएगा? रो जी इंटू एच टू, बिकॉज एट दिस पॉइंट लेवल इज दिस वन, दिस पॉइंट लेवल इज दिस वन. सो यहाँ पर प्रेशर कितना होगा फ्रेंड्स? इफ यू ड्रॉ द प्रेशर डायग्राम, if you draw the pressure diagram, this is the pressure, it is equivalent to the rho g into h1 at this point, and it will be like this. At point, this point pressure is 0 and this point pressure is maximum, so it will work like this. If you, this is the pressure diagram. Here also the pressure is equal to what? Rho g into h2. And it will be pressure diagram, it will come like this. So at this point pressure forces will work in this direction, and at this point pressure forces will work in this direction. This is the pressure diagram. This point is, let's assume L, M, and this point is N and O. Okay friends, getting? Now the same thing is there in this diagram. This is the pressure forces. Here force F1 is working and here force F2 is working. This height is S2 and here this height is S1. Here the pressure force is working rho g H1, rho g S2. Okay friends, now Now friends, the pressure force, F1 is equal to what? The pressure force F1 is equal to what here? F1 is equal to this diagram show the pressure force into width. It means, see here friends, the pressure we can calculate F1, this F1 equal to the triangle area of the triangle into width is the pressure force, or we can say here this it is equivalent to the pressure into area. We can say pressure into area. Same thing it will come by like this here, pressure diagram into width, area of this triangle into width, it will give the pressure at F1. Similarly, triangle area of the triangle into width, it will give the pressure force at F2. So we can find here friends, you see area of the triangle is equal to what? Area of the triangle is equal to 1 by 2 into height AM into this base LM into width. Let's suppose width is equal to B. So from here, this F1 is equal to 1 by 2 height is equal to AM and base is equal to what? Base is equal to this LM. Or we can say friends, from here already we discussed this P into area. So here you see area is equal to what? If this plane we are taking, so H1 is the height and width is equal to B. So area is equal to what? Area is equal to, from here, this is area. Area is equal to H1 into B. Pressure is equal to what? Into pressure is equal to rho G H1. So friends, something mistake is here. Something we will clarify. I will clarify this one. This point. Let's first we see. First we see here. I will clear this point. First, we just to understand this F1 equal to half into area, area of this triangle into width B. So F1 is equal to 1 by 2 into AM into LM into B is the force. So 1 by 2 into H1 into height is equal to H1 into pressure is equal to rho G H1 into width is equal to B. So from here the pressure force will come 1 by 2 into H1 into rho G H1 into B equal to B rho G H1 square H1 square divided by 2. It will come. Okay. And similar F2 is equal to what? 1 by 2 into this area of this triangle, 1 by 2 into this height BN into OB into width. So 1 by 2 into BN into ON into B. So 1 by 2 into S2 into rho G S2 into width B. So rho G B S2 square by 2. Okay friends. So from here F1 is equal to rho G B H1 square by 2 and F2 is equal to rho G B H2 square by 2. So friends, here this F1 at this point and F2 is this point. So what is the difference? So force required to accelerate, जो यहाँ पर जो है हमें एक्सेलरेशन फोर्स मिल रहा है, जो एक्सेलरेशन फोर्स मिल रहा है वह क्या होगा? डिफरेंस इन द फोर्सेस वर्किंग एट दिस पॉइंट एंड दिस पॉइंट. So F acceleration force required to accelerate, F acceleration force is equal to F1 minus F2, or we can say F acceleration is equal to F1 minus F2 equal to rho GB H1 square by 2 minus rho GB H2 square by 2. Or from here acceleration is equal to mass into A equal to F1 minus F2. It will give the same value. Whatever mass into acceleration is there, same thing it will give by F1 and F2. So this is the accelerating force. Okay friends. Now one doubt is there. This doubt friends I will try to clear from book. Otherwise I will explain this one in the next class why it is coming. Friends, from here I think it is clear or not. From here, if this book is RK BANSHAL, page number 112 fluid mechanics, page number 112 fluid mechanics. So from here, this F1 is equal to same thing, rho GB H1 square by 2, and here rho GB H2 square by 2. We can find here also rho G A1 H1 bar. So from here it is saying that the value of F1 F2 can also be obtained as it is saying 3.3a. So F1 is equal to rho G H1 bar into A1. A1 is equal to H1 into B, correct? And this H1 bar is equal to what? H1 bar is equal to H1 by 2 it is considering. So friends, what it is considering here, F1 is equal to rho G H1 bar it is considering into area, and it is considering here area is equal to this point is equal to H1 and width is equal to B. So area is equal to what? Area is equal to H1 into B. So here rho G H1 bar into area is equal to H1 into B. And here friends it is considering this H1 bar is equal to H1 by 2. So from here the force F1 is equal to rho G H1 by 2 into H1 into B is there. So from here same thing it will come, rho G B H1 square by 2 F1. Friends, it is getting clear. Otherwise I will see and explain again. Okay friends. But the same thing is there. आप calculate करेंगे. If you will see, then you are able to understand. It will come the same thing. F1 is equal to B rho G H1 square by 2 and F2 is equal to rho G H2 square by 2 B, like this. And the accelerating force F acceleration will give the F1 minus F2 is the F acceleration, or we can say mass into acceleration. Getting friends? Hope the thing is clear. If any doubt is there, please comment. I will try to clarify it. थैंक यू फ्रेंड्स. फ्रेंड्स मेरा एक्सप्लेनेशन अच्छा लगे प्लीज़ लाइक कीजिए, कमेंट कीजिए, मेरे चैनल को सब्सक्राइब कीजिए फ्रेंड्स. थैंक यू.